All right. Hello, WebAssembly Fermyon friends. Thanks for tuning in to another episode of Fermyon Live. Today we're going to talk about the JavaScript SDK, show you latest improvements, and yeah, build something from scratch, right? And I'm happy to have Karthik with me on the stream. Karthik, you may introduce yourself.
Hello, I am Karthik Ganesharam. I'm a software engineer at Fermyon, and I usually work on the JavaScript tooling for WebAssembly. And I'm excited to talk about the JavaScript SDK today.
So you're the go-to person when it comes to all the things Spin in TypeScript and JavaScript, right? Yes is the answer. At least to me, if I got stuck with something or I have questions, we immediately jump on a huddle or on a video chat and bounce ideas and figure out things. Yeah, so we talked about doing this episode to give you a heads up on what we have recently changed within the Spin SDK for JavaScript and or TypeScript. And yeah, why not diving into it from top to bottom, right? So starting with a quick overview and then going to build something, right?
Yeah, I think we can even start with just creating a new app and looking at how it looks, and we can then compare what has changed from the previous version to the latest.
All right, so should I bring your screen to the stage?
Yep.
All right, there we go. Maybe you can bump the fonts a little bit.
Is that good?
One more, do one more.
It looks massive on my screen, but yeah.
It looks massive on yours. Okay, then we will stick with that. But people tuning in from YouTube, if you want Karthik to bump the font size even more, let's just know. So. All right. So you have installed maybe before you start or create the app. So you have installed, I assume, latest and greatest Spin CLI and some, let's say, recent version of Node.js on your machine.
Yeah.
Okay. So this is I think it's Node version, is it? Yeah. Yep. Okay. So this is the Canary build of Spin. So this is really latest. Yeah, really latest and greatest and latest Node.js. Okay, great. So with those things installed on developer's machine, everyone should be good to go, right?
Yeah, those are and you'd also have to install the templates for the TypeScript thing. And so how one would go about doing that is you can do spin templates, install. Since I already have it, I have the update flag and git. Since the repositories have recently moved to the Spin framework organization,
Okay, so this is you basically updating the already pre-installed templates, because if one uses the installer script or, for example, the brew tab that we provide, then one should end up with HTTP.js, HTTP.ts, and the corresponding Redis templates already installed on their machines, right?
Yep. They would. Yeah. It's always good to just update to the latest, since we are talking about the latest and greatest in the SDK.
Yeah, that's right. So we tie the templates to the Spin releases, right? So if you have whatever version of Spin CLI, you will always end up with let's say a version of the templates that works with your Spin CLI installation. Yeah. But it's, as Karthik mentioned, it's a super good practice to check for updated templates every now and then. And that's why we're here, right? We recently updated the templates for both TypeScript and JavaScript, especially the HTTP ones, which we will explore right now. And if I remember correctly, I saw you already typing HTTPS, so we are going to write TypeScript, right?
Yep. So,
Awesome.
and I have given the app the name Hello World, and it asks us for a description. It's fine to leave it empty for now. And then the HTTP path at which this component is going to be served, we are saying wildcard from the root. So anywhere you hit, just serve this component is what this describes. So now we can see that we have created a new app called Hello World. The first thing we want to look at is the spin.toml, which describes our Spin application. So we can see that it's a Spin application which has one component, the Hello World component, and there is a source of where it can find the WASM module. And this is this just describes how the app is going to look. And if we go look at the index.ts, we see we already have a template with some code in there, which is basically using the auto router from the ET router package. And then we just say on the slash, we say hello universe. And when we say hello slash name, it's going to return a hello, whatever the name was in the path. And then we just add it to the event listener. This is the biggest change that has happened from the SDK, where previously we were wrapping it with a export called the response builder, which allowed you, which you had to write differently. Now this is more in line with standard JavaScript serverless code that you can find on the internet. Like this is now up to the service worker spec. This is because Starling Monkey has updated enough to give us enough built-ins. And when I mention Starling Monkey, it's the underlying JavaScript engine we use to execute JavaScript inside WASM.
Yeah, maybe let's pause here for a second. So, I mean, the obvious question would be, hey, why do we have those red squiggle lines under your code?
Yeah.
But I assume that's an easy to fix thing, right? So
Yeah.
we have not installed yet the dependencies. Like, right, we have chosen to roll with the auto router provided from ET router, and those dependencies, there we go. They are listed in the package JSON as you would expect them to be from a Node.js JavaScript TypeScript project. So for sake of demonstration, we are now executing npm install manually, right?
Yeah. Also, it is part of the build script. Like if we go and look at the spin.toml again, we can see there is a component build section where we describe how to build it. We also run npm install on it. So if we just ran spin build, which we will in a moment to build our component, it would have automatically ran npm install and then would have run npm run build after.
Yeah,
npm.
that was just me asking, right? Because there were those squiggle lines, but now they're gone, right? Because right now the language server is able to discover the dependencies that we were using, and with that we get, you know, all the great IDE or editor capabilities like IntelliSense, CodeLens, and whatnot, right?
Yeah.
All right.
So then,
So maybe reiterating over it. So with the Spin SDK for JavaScript 3.0, we introduced Starling Monkey as the new runtime, or the new runtime that Spin uses under the covers to run your JavaScript code in WebAssembly, right? And
the one thing I
sorry.
was going to add there was basically Starling Monkey has been a part since the 2.0 version of the SDK because we have started using componentized JS. But the biggest update is like the engine has gone through several updates now, which means that it supports a lot more of the service worker spec, which makes it a lot easier to use more of the libraries and more applications possible to run without running into API not found kind of issues, which you will still run into, but much less often now since we are getting closer and closer to the complete spec.
Okay, I see. But this, right, as you already mentioned, line 14 14 to 16, this looks like super like common in JavaScript ecosystem or Node ecosystem. It's like registering an event listener for, the fetch operation and then run basically our component to completion.
Yeah.
Yep. All right. So I'm going silent for a second.
Yeah. Let's just build the first component as it is, and then we can go about editing and adding things to it. So spin build is the command that's used in a spin workflow to build your component. So what spin build does is it takes the command we have defined under the build section and runs it one after the other. And with that, we once that spin build is done, we can see the component has been written successfully. And like if we go into the dist folder, we see a hello world.wasm that is described as the source here. So now that we have our component, let's run the component. Let's run our spin app. So to run the app, you just do a spin up, which basically reads the manifest and sets things up and runs the application for you. And we can see the app is running now, and it says there is one component listening at the root as a wildcard. So as we saw earlier in the code, when we do a slash, so let's just request to the root. We can see hello universe. That's what we get. And let's say slash hello spin, we get hello spin back. That's the second route. What happens if we hit a route that does not exist? Let's say bye, and you get a status 404. Like this is a bigger change, like because previously we used to bundle it router in our SDK, which was stuck at version 3. And since we upgraded it to V3 of the SDK, we have stopped bundling the router, which allows you a greater flexibility of using the router of your choice. We have just chosen it router as the default for templates, but you could always swap it out for something like Hono if that's your preferred router. And decoupling it means that you're able to use more later routers. For example, the auto router was not a thing in V2 of the SDK. So it adds the auto 404 on routes not found, which is a nice addition here.
Yeah. So yeah, again, so obviously we dropped some of the API capabilities to do so, right? So previously there were like different, let's say, values or modules that we exported as part of the Spin SDK for TypeScript and JavaScript. But with the recent release, we decided to integrate in a nicer way with whatever's out there. So we are making less assumptions of how developers would want to build their apps. Instead, we give them like the freedom to choose from whatever's out there, right?
Yeah.
Okay. Okay, this is great. So, yeah, and I expect like the router offering all the capabilities that one would expect from an HTTP router. So, should we maybe add a new or an additional route to, yeah, maybe accept some data over HTTP? Yeah, that's great.
What do we want to call the route? Like, let's say store item, for example.
Yep.
And
okay.
The function's going to, currently we're not going to store it anywhere, but let's just process the data and say we received, let's just console log it. Console.log, you can, I'm going to JSON, that's fine. And return new response item stored. So once we have done this, we can just go ahead. And the other nice feature is when we do changes and we save, we can always, Spin does have a watch feature. So you can do spin watch, which should build things.
Yep. So this is basically watching all the TypeScript files and recompiling on the fly. Yep. Okay.
I need to quickly spin.toml. Yeah, that's fine. So we say these are the files you need to watch for and changes.
Yeah. Yeah.
So that's
exactly.
And then when you can go here, curl localhost 3000 store item. let's say this is the data we send. Did I not? What is happening?
Oh, you're sending a GET request, I
No,
assume.
just sending minus uh,
All
D
right.
should be the post request. But let's
Store. Oh, there you're missing a slash in the route registration.
ah
There you go. There's yeah.
yeah, that was it. And now we can wait for it to rebuild.
Yeah. Okay, so now we got a new version of our app running, and
We can see
I
item stored, and if you go back here, we can see the log, which has just printed whatever we sent there.
yeah, so that's great. I was spending some time with the latest improvements that we did to the Spin SDK for JavaScript TypeScript, and I found it super convenient that the ITER router also so by relying on the auto router right now and not re-exporting it, right? We can also use all those convenient or the syntactic sugar, so to say, provided by the ED router package. So they have like super convenient methods for returning, let's say, a JSON payload with an HTTP status code 200, proper headers set, and so on and so forth. So that's
Yeah,
definitely worth checking out the ED router module or package with all its helper methods and functions that are exported, because this is like different from the way you would normally build an API like that with previous releases of the Spin SDK. So this return new response, there was a whole different experience. That was a whole different experience with
yeah,
earlier versions, right?
yeah. This is more standard of what's up to the spec. Like previously, we had our own custom API. Now it's
Hmm.
become more spec. And like you mentioned, like the modules that ET router offers are pretty nice. Like for example, they have middlewares for cookie parsing or like getting your body, and those things work out of the box, which is quite nice here.
Okay, if we go one step further, so this is like, okay, we have the router, right? We can register, get, post, put, whatever routes I assume. um, let's say, or let's go ahead and add a variable to our application so that we
Yeah,
could, pick something up that may be different from the environment where we execute our
yeah.
application.
It's not called environment. It's called
Variables, yeah.
yeah. And then we can define it as what do we want to call? I always get stuck trying to come up with things quickly.
Yeah. I don't know, maybe color.
Yeah, let's just call it color,
Okay.
and let's go with red.
Okay.
And it
So, I
started
mean,
building.
obviously, you could uh, introduce like a global variables table in the spin toml, and then pass the value for color from the CLI or from the
Yeah,
runtime environment to the app. But this is like the super easiest way to say, hey, this component, the Hello World component, right now has access to a variable called color, and the value is
yeah.
red for now. Okay. Um, so how
Uh,
would one right now access this one?
so the Spin SDK supports variables. As you can see, the type system is already showing up,
Mhm,
and you can import variables, and then you can like. I'm just gonna read the variable first, and then I can show you how it's piped down the router for
mhm,
where to use it. So we can just do console. Let's say let value let or color variables that get color,
mhm.
and you can, if you hover over it, you will see the type is either string or null, and you can see
All right.
that it returns null if it does not exist.
Mhm,
And you can do console.log color, and you can just do it here. Or
mhm,
if we just want to pass it down the router, um, so the router.fetch takes a second argument, which is a context, and which is basically an object where you can pass arbitrary things, and that will be passed the caller, the handler function. So instead of printing it here, let's do a get color. We don't want to do variables dot get color. We can just use what is passed.
The context, right? Yeah. Yeah. Okay, so now you're destructuring the context.
Yeah. And we can just return the color. Because router also automatically converts strings to responses, so we can just return the string.
Okay, so the first argument of that closure is basically the request. Is that correct? Yeah. The underscore that you specified in line 17. Okay. Okay, cool. So meaning if you send a request right now to /color, we accept to get back red.
Yeah. We can see red as the response back.
There we go. So this is like this is now a little like an alternative approach, let's say it that way, to using or to rely on ED's middleware.
Yeah.
Middleware concept. Any preference? So I would roll with middlewares for the sake of embracing like the all the capabilities provided by the router. But this obviously, allows you to swap the ED router with another router and not have to rework all your middlewares, right?
Yeah, pretty much. This basically allows you to add it as context, and you can do it one way or the other. Like sometimes middlewares might be nicer when you want to apply it only to specific. Like for example, this argument is now getting passed to all the calls. It's just not utilized by any of these handlers. But if you want to so like constrain it to be only applied on certain routes, like you don't want to read a variable on every route, you can write a middleware and apply the middleware selectively instead of all the routes.
I see. But if we sticking with this scenario, so we have some sort of configuration data right now. It is it is the color, right?
Yeah.
And as you mentioned, it's either a string or null, and so we could do like in line 22 or line behind line 21, we could do like a simple Boolean check to check if the variable is set or not. And could we respond to the event by simply sending back a new response saying, I don't know, 500, whatever necessary or required configuration not set?
If not color, we don't want this. You can just do event dot respond with, and you can do status 400. Although this should be a 500 because
it should be 500. Yeah, user can't do anything about us not providing the configuration value. Yeah,
and this should just return the response. So we can go into our spin.toml and we can just comment this part.
Oh, this. Yeah. Maybe you can set it to an empty string.
It shouldn't matter per se. Though.
Okay. Okay.
And I don't. Yeah. Is it ready? Is it not?
Let's see. No, it's not. It's not ready yet.
I'm gonna stop spin watch.
Okay.
And we get set, and let's do a -i, which is status 500.
That's great. Okay, so you could basically guard your application from starting without required configuration data being provided. We got a question from Tumalo. Let me add that one. Hi, is there a different way of logging with support for different levels, info error, and how to change the name of the trace to drop to anything other than spin? I think he's referring to other than spin.
Are we
So
talking logs from Spin? I'm not
yeah,
entirely.
yeah, I think we're Tumulo, maybe you can correct us if we are wrong, but let's start by diving into guest logging, right, and how that works. Maybe I think it's easier to uncover it from that one. Oh, he's talking open telemetry, but let's first because I think guest logging should be pretty easy to cover, and then we can look into telemetry, right?
Yeah.
So for guest logging, it's basically everything you write to standard out or standard error will be forwarded by Spin from your guest code to the host. So that's the way how you could write to whatever the underlying platform is. And maybe if you're considering things like, let's say Spin Cube, for example, you can have other components deployed to your Kubernetes cluster that take those logs and process them and push them into whatever log aggregation systems in there. If we're talking about open telemetry, maybe we can simply. Do you have the OTel plugin installed, Karthik?
I might. I'm
So
not sure how updated it is.
now we are nicely going off script. Not that we had a script, but okay. So we have the hotel plugin, and I think that's pretty. Well, it's super convenient on how to get started with making your Spin app gathering telemetry or exporting telemetry data to a hotel collector.
Yeah.
And there are currently two stacks that you could run using your local Docker setup with the hotel plugin. One is, I think it's a PLG stack, so Prometheus, Grafana, Loki, and not to forget Jaeger. And the other one is .NET Aspire. So if you do a Spin Hotel setup -- help, you should see that there are. Oh,
Just keep stuff.
yeah, Spin Hotel setup help. Exactly. And there you, by default, so PLG is the default stack. However, if Karthik, if you have Docker running on your machine,
Yeah.
yep. So passing the Aspire flag would dramatically speed up things because Aspire is like a single container observability stack that you could use.
Yep.
Okay, so basically it's doing a Spin hotel up.
And I think I need to share.
Oh, you have Spin still running in the secondary. Yeah, turn up. Great.
Oh, I'm in the wrong folder.
Wrong folder. There we go. So this basically enables like the old hotel machinery, so to say, that Spin will gather those metrics and export them to the hotel P exporter. So as far as I know, all those. So now that we have everyone on the same track, that everyone knows what we're talking about, I don't think that users can customize the telemetry trace or how the service. I think it's called service in hotel terms. How the service is referred to, right?
Yeah.
If I remember correctly, that's. Oh, what are you looking for?
No, I'm just trying to open the trace in case we wanted
Yeah.
to just look at it.
Yeah, it's a Spin hotel open Aspire.
Yeah. And it probably requires me to
Share
yeah.
share more than just your editor, right?
Yeah. Give me one. I have not used Aspire, so things look super new to me.
Yeah, I think you have to re-share your screen otherwise in order to share it with us, because we're just seeing
Yep.
your
Yeah, I'm just moving things around quickly.
Sure.
I'm going to do the
Take your time.
I do not know how big slash small things look, so I just
Okay.
set it.
Oh, that's good. Yep. Maybe let me quickly, let's make it, can we do it a little bigger? There, like this. Okay.
I can zoom into.
Okay. If you go to or send some requests to, yeah, there we are. Yeah.
Oh, it's
So
view.
we are. Yeah.
We can see traces for the app that we.
Oh, can you bump the font size?
Yep.
Yeah, there we go. So yeah, Tumalo, as you can see, we get obviously we get the traces, and I guess that's what you're actually referring to is how to customize the service name shown over here, because it is a spin as runtime receiving the request hitting the listener, right? And then we see execute wasm. I think it's wasm component, right? The second
Yeah.
span. Yeah. Yeah, exactly. So that's telling, hey, the spin runtime has figured out that this request is meant to be forwarded to the hello world component. So that one gets, loaded, and then it gets instantiated and executed. And then we have our guest code again calling to a host API, so loading variables as they are defined in SpinTommel,
Yeah.
which results in an additional span being produced on the OTLP protocol. But so
The trace here kind of says error unavailable, but what the SDK does is it handles the error for you and returns a null instead. That's the difference. That's because JavaScript, it's more common to not throw exceptions, but like return a null if the resource does not exist. So to
hmm.
make it more idiomatic, the SDK does the error handling for you.
Oh, that was why I was, just jumping in and saying, hey, maybe we want to roll with an empty string, because I wasn't aware if that error is caught or if we have to catch it by ourselves. Yeah.
Yeah. So the SDK catches it.
Okay. Okay. So to answer your question, no, you can't modify the service name as of now. But maybe it's definitely worth flagging an issue on the Spin SDK, on the Spin repository, sorry. And so that we can at least look into that and have a discussion on what you're actually looking for and how we could support you in getting that. And I will grab the new URL. Give me a second. Karthik, in the meantime, maybe you can move on with the sample application, can't you?
Yeah. Let's. So the sample application is. I assume you're talking about the Olama application.
We could look into Llama, yes.
I wasn't sure which sample you were referring to. So
Oh, good. Oh, good. So let me quickly bring in this one. There we go. So this is basically the new home of the Spin repository, since Spin has been accepted by the CNCF and is right now a project on the sandbox tier. Spin and all its sub-repositories like the Spin SDK for JavaScript, which we are exploring as of today, resist right now under github.com/spin framework, which is the new organization and a new home for all the spin-related code. Yeah, and as Karthik already spoilered, our idea is, or maybe you can switch again to sharing just yet the window, because right now the font size is super tiny.
yeah.
Yeah, so as Karthik already spoiled, our intention is to bring in some AI, so to say. What I've prepared in advance of the stream is I have created a virtual PC or virtual machine in the cloud, deployed Ollama to it, and deployed DeepSeek as a model, as a large language model onto that Ollama server. And I have made it accessible from outside of that virtual machine. And the idea why we've chosen an AI example over here is not for the sake of AI, it's more for the sake of illustrating that you can use existing node modules that are out there that use, for example, that rely on the fetch API or other service worker APIs that are now supported by the Spin SDK for JavaScript and TypeScript. Is your plan to add that to the Hello World application?
Yeah, I was just going to write a simple thing instead of the entire application. We could definitely show the entire application too.
No. So go ahead. Just curiosity, just asking.
Yeah. It was more of, it's easier to explain what we are doing as if we just do it step by step is what I thought. So like we can obviously, after we do the first step, we can always go back to the original code and just run it.
Okay, but I think there was already an interesting part while I was talking, and that was you basically doing npm install. So you installed like a couple of things from LangChain. So obviously we are using LangChain JS right now, right? So there's the core package, there's the Ollama package. Those were the two LangChain dependencies you added, and then you added a third thing, which is the abort controller polyfill. Do you want to explain why, what?
So like we mentioned in the past, we use Starling Monkey, which is derived, which is based on the Spider Monkey engine. But the Starling Monkey engine is not completely up to the spec or the service worker spec yet, so it kind of misses the abort controller. And the LangChain library kind of relies on the abort controller. So until it is implemented upstream, which is being tracked in an issue, so we are using a polyfill to get around it, the limitation for now. And once we have support for it in the upstream Starling Monkey and it comes down into the SDK, we can stop using the polyfill and just use the native implementation.
Okay, so this is like a requirement as of today. Okay.
Yeah, this is basically a stopgap solution.
Yeah. Okay, so you added your JavaScript Node.js dependencies as you would normally do. Then you bring in this polyfill to have that abort controller being like implemented in somewhere.
Yeah. So what the polyfill basically does is it just patches fetch and adds a signal to it. So it with a new implementation for abort controller stuff. So it just works. So basically just importing it here means it's modifying fetch in the global scope.
Okay. Yeah. Cool. So next will be, obviously we have to send some prompt to the large language model. So I would expect us to have like a post endpoint where we can simply send a maybe a JSON or maybe text, whatever works for you.
Text is the easiest.
Okay. So you're a friend of using those inline functions. I would rather.
It depends. If I'm writing only one thing, then inline is fine. If I'm writing multiple routes, I prefer to split them out. And since you're writing only one route here.
Oh, could we be a little bit more explicit than accepting all endpoints? Maybe /, I don't know. Yeah, something like that.
Yeah, and I'm going to quickly open the Ollama API on the side because I have not used this library more than once.
I can also guide you through some of the
that would be very useful.
Okay, so the idea the idea is to start with with a prompt template. So a prompt template is basically a string. Maybe you can define in line 13 a const. I would say a system prompt, or yeah, maybe there const system prompt equals, and that's basically a multi-line string.
Yeah.
Yeah. So we have deployed DeepSeek to it as a context, right? And DeepSeek has, so what I found or discovered up until now is that it has like an XML-like syntax where you have exactly context, where you can say, hey, you're an, I don't know, a super powerful AI assistant helping users to do X, Y, Z.
Yeah.
And once you've set context on the set, there's a sibling node, I would say, user, where we can just in curly braces place user prompt there.
After
So
context, you want.
you have after context, I want a user.
Okay.
User, exactly. And as the content of user just set it to wrapped surrounded by curly braces. Yeah, for example. Okay. That's it. So because LangChain.js is giving us a so-called prompt template that we can use and say, hey, this is my system prompt. And by the way, here is a JavaScript object with, I don't know, variables. One would be query. And then LangChain is able to, merge it together, and then we can pass that over to our chain. So, okay, what we would first do is maybe we move to, oh yeah, almost. So from prompt template dot from template, no, that's Rust.
Yep.
And it's not new prompt temp. Yeah, that looks better. Okay, so here I would pause because yeah, we have to create a new instance of Ollama, but that's something. So the Ollama object basically takes the HTTP endpoint, which is where the Ollama server resists. It takes things like, let's say, the model you want to invoke and the temperature you want to specify and other, metadata. So I think we could start by hard coding it and moving all the way towards configuration, or we could start with the configuration approach first, whatever you're up to.
I think we can start with hard coding because the configuration is the same as doing the color.
Okay, so the Ollama constructor, new Ollama, takes an object with, I would specify this base URL property as a string, the model as a string, and the temperature as a floating point number between, model, exactly. That will also be a string, and I will give you the corresponding values in a second. And the next one is temperature, which should be something along those lines. Okay. So as I said, I have deployed a DeepSeek Ollama instance in the first place with a DeepSeek model. So I've just sent you in chat the IP address, and let me also give you the model identifier. Which is super simple. It's just DeepSeek-R1 latest. Okay, so with the Ollama instance, we can use the prompt.pipe.
Yeah.
And pass in the Ollama. So prompt.pipe, pass in the Ollama instance. Right, that gives you basically what's called a chain. So const chain. Yeah, exactly. And with the chain, we can then call the invoke method. That's an async method. So we
I
await.
assume it gives us a response.
Yeah, ultimately we get back a response. So we have to await chain.invoke. And invoke takes right now that object where we can bring in our contextual information, like our, query, as you specified it in line 12, right? Because then we can, marry the system prompt with all the instructions and the user provided. So
We have to make this async. So it's
okay, and yep, with that, I think we can simply construct an HTTP response and passing back response. Response should be string. Can you double check what we get back from the invoke?
pure string.
A pure string. Okay, maybe yeah. Then text plain.
It's all Copilot generating things. So.
Oh. Okay. We will see. This is nice. We use that syntax for response for the first time right now. So instead, in addition to passing in the response payload, you specify an object where you can customize the headers, and I assume you can also specify status code.
Yep, you can specify status code and everything that you would expect on a response object, which is a part of the fetch API.
Okay, cool. Mm-hmm.
So one thing we'd have to do is, since we have an outbound URL, we are supposed to add it to our allowed outbound host because Spin does component capabilities.
Yeah. And all
I really
outbound.
wish Copilot knew about outbound hosts.
Yeah.
I can't wait for the data. Like where Copilot, or maybe not. I don't know how I feel about it.
All right, yeah. So we must explicitly grant the permission, the component the permission to do outbound HTTP in that case to the API exposed at, what is it, 172 and so on and so forth. Okay, this looks good. Maybe it's time to give it a shot, right?
Yep. Let's
So I
just
mean, right now we still have hard coded a couple of things, starting with the URLs, also the query.
Oh, what is it not? Oh, it's the location.origin. Did we not solve this? Oh,
Check.
this was because we had to hard code the lang chain. Something changed then.
Oh yeah, LangChain 1.0.1.5. You're right.
So this is an issue because an upstream thing has changed how it's accessing location.origin outside, and this is something we are looking into how to fix because currently in WebAssembly you do not have access to certain globals during initialization time.
Yeah.
There is something called wisening which happens so that your runtime is low. Like when you do a spin build, anything on the global scope is evaluated and run. And so because the updated did I yeah, we shouldn't have this either. So basically, anything in the global scope gets executed and the value is snapshotted. So basically, what was happening was it changed in 0.1.6, where the location.origin was being accessed whenever you imported this, which meant, and currently the Starling Monkey does not support accessing the origin outside the handler function. So that's why we saw an error saying location.origin reached or called, and that panicked. We are
Yeah, but
looking at possible solutions.
right, we were already discussing that and how to address that that issue. Yeah. All right. So with a WASM file in place, we can do spin up, right?
Or maybe we should do spin hotel up since we have the hotel stack running.
Yeah, but you've just shared that one. Okay, so it's time to send a request here. So Just a expectation management. I have not provisioned the biggest GPU out there, so I expect it to take a couple of seconds to do the actual AI inferencing. So yeah, sorry for that, but it's
Well, it wasn't
still.
too bad. It was
It
fast
wasn't
enough.
too bad. It was fast enough. So this is, yeah, maybe you can increase the terminal a little bit, because I think this is, if people have never interacted or worked with DeepSeek, this is super interesting because in the first place, I was a little bit puzzled maybe when I explored DeepSeek in the first place. But in the meantime, I really like the approach of giving us as the caller, right? All the reasoning behind how the AI or how the large language model generates the response. And although we have like a super simple prompt, and the system prompt is also super minimal, we can see the different steps that the LLM does in order to come to the conclusion that the capital of France is Paris, which is right.
Yeah.
But it's super interesting if we, if you have scenarios with a more sophisticated system prompt where you actually can follow the large language model connecting the different dots and making assumptions, which is not just, maybe it's not the best answer for your prompt at that given time, but you can use this information about the reasoning again to improve your prompt engineering capabilities on the fly. So I really like that approach of giving me all the reasoning behind the answer that it's basically responding with.
Yeah. Now I kind of like how it mentioned Paris is a major city and people are proud that it's a capital. And then it went on thinking about other things, but it's quite interesting to see how it got there.
And should I should make sure there aren't any other capitals I'm confusing with. For example, Spain's capital is Madrid. Nice. So France being Paris fits in it.
Yeah.
Yeah, that's nice. All right.
Yeah.
So do we want to clean this thing a little or make it a little bit more realistic? So
Yeah.
obviously we hard coded a bunch of stuff. So I would assume us, yes, to maybe take the prompt from the request.
Let's call it query.
Yeah. Nice. Okay. Yeah.
Query.
Yeah. If not query, then I would simply return bad request. Yeah. Yeah. That's nice. Okay. So one fixed, two to go. I think the temperature, we could, keep the temperature like as a const value in source code, but maybe the model and the endpoint, those would potentially be configuration values that I want to specify when deploying the application, or when running it locally. I want to use spin variables.
Let's put the model in the path.
Okay. But
forget.
that would allow the user to mess up when the user passes a wrong string, or maybe a model that we haven't deployed to the Olama server. So
I'm basically.
I have strong opinions towards using WASI config. Just saying.
I mean, this allows you, like, assuming we have multiple models, you are able to define what it is. Just an example, like I just wanted to put the model on the URL path to show how it is parsed.
Okay. Okay.
And
Cool.
the others, although I forget how this is done. And
There we go. I see. I expect us to use WASI config, and
okay, you have sold me on it. I forget the exact thing. That's the thing
there
with
we
the
go.
tool.
There we go.
Always
There we go.
default hello.
And I would never trust the client from sending me the model name. Yeah.
Oh, That's why I was going to write a mapping, and if you sent the wrong thing, I was going to write.
Okay.
It doesn't matter now.
I see. Do we wanna add a global variables table also, so that
Yeah,
we
we can do
can
that.
cool? Because then I would start with that one.
Yep.
Because that, it makes it easier to explain how things are wired up. So first let's say let's call the first variable Olama or whatever. Oh yeah, let's call it model. Okay. And this is equal to an object required true.
I do not like Copilot prompting me wrong things here.
Yeah, true. Okay. And the second one is base URL, whatever, or endpoint. Okay. So by defining those application-wide variables, we can make use of interpolation when defining the variables provided to a component. So over here, it's double curly braces and then the name of the application variable, right? So this is just, simply piping the value, but also we can use it to configure our allowed outbound hosts, right?
Yeah.
So instead of hard coding the URL over there, we can also use the endpoint, right? And now it's just a matter of following the pattern that you did with the first app we implemented. Oh, you're doing it that way? Okay.
As in, did you want to do it outside and pass it there?
Yeah, I would prefer doing it outside and failing if either of those values is falsy. You know, and only call it with, valid information.
Yeah, that makes sense.
Are you by the way, are you coding on your new split keyboard?
I thought that would have been obvious, but yes, with me struggling around with the keys.
Yeah, so a bunch of Fermyon team members swapped to fancy split keyboards. But for the sake of doing a live stream, I decided to roll with the other one because my words per minute count is still a little low.
Mine's pretty bad, but I'm okay with it. I'm powering through it.
Yeah. Cool. So now again, okay, you're pulling the values from that, what's it called? Extras? No, context dimension. Context, yeah. Oh, it's the other way around. It's the other way around. It's
I should have done. I don't know why I decided to rename the key, but
okay. So the global listener, can you show me the global listener? I was messing around with mechanical split keyboards at the meantime. Endpoint. Okay, that looks good.
Yeah, and now we can go back here. First thing you want to do is spin build. What is the spin?
Oh, spin underscore variable, and then in uppercase, no, variable singular, yes, and then uppercase the variable name. So model
equals, let me copy them.
Yeah.
Variable endpoint. Yep. So
all right. So now it's. Oh, I think now we have to pass the actual query, right? Yeah.
I'm just curious what it's going to think.
Yeah.
It got the right.
Hey, it got right. Yeah.
Yeah, I love the reasoning here.
Yeah, that's great. That's great. But with that, I think we are in a pretty good shape for
Yeah.
that for the spin application that is relying on LangChain as just an example, a node package from the community, so to say, um, which itself is using Fetch API under the covers to interact with the Ollama API exposed by our Ollama server. So we use that polyfill to handle like the upward controller case. Anything else that you want to point out in the context of the new Spin SDK or the latest improvements made to the Spin SDK for JavaScript and TypeScript?
There are a lot more as time there are a lot more of the upstream APIs in progress, and like once they land, we should have access to more, which will enable us to build more things. But I feel like we are at a point where we can build lots of varieties of apps with the existing API, and soon enough we should have other form data on the request object APIs. And if there are any APIs that you see missing, you can feel free to open an issue, and then we can see how to prioritize that, or depending on what applications you're building. So the upstream link for Starling Monkey would be, let me get the link.
Yeah, just
I cannot paste the link. I think Thorsten, can you paste
oh,
the Starling?
just yeah. Do you have it on hand?
I do. I will paste it in the chat to you.
Yeah, sure. Okay, cool. So I will forward that one to the chat on YouTube, and also let me quickly introduce a new banner for that one. So there you go, Starling Monkey. Yes, I think we mentioned that it is a Bytecode Alliance project at the beginning that we use as part of the Spin SDK to run your TypeScript or ultimately the JavaScript code inside of WebAssembly.
Yeah.
Cool. This is great. So, summarizing what we saw today, we made some, I think, super great improvements to the JavaScript SDK to make it more idiomatic, right? Oh, the entire structure, right? So you have right now a build and a dist folder. We tried to clean up the, let's say, in air quotes, the project folder. So that's the folder of your Spin app as much as possible, right?
Yeah.
And we got feedback that it would be super handy that if you do a Spin build and you haven't done an npm install yet, that it automatically installs the dependencies. And maybe last question to you, Karthik, in regards to the Spin SDK. If I remember correctly, you did some, hashing of
Yeah.
bundled assets and stuff like that to build the WASM component only if there's need for building it, right?
I was just going to mention it. Like one of the subtle changes is we have improved the build experience instead of having to componentize every time, which takes a chunk of time.
Yeah.
We now do hashing. So if you go and look at the build directory, you will see a build data, which basically checks for what version of componentized JS you've used to build the last one, and the checksum of the input. As long as
Mhm.
those don't change, your output should not change. So we have kind of short circuited it. So your developer loop becomes faster if you do not change anything on your JavaScript app, but you change only on your front end app, only that gets built, while this just short circuits and does not go through an unnecessary componentization step.
Yeah, that's great. Yeah, so we tried pretty hard to make it as smooth as possible and to make it look like a regular JavaScript Node.js project, right?
Yeah.
Cool. Anything else you want to share or mention or call out or?
Basically, if people use things and feel there could be certain improvements, issues are always welcome for us to track it, and we can discuss about it. Like if there are new features you would like, or if certain libraries that you use do not work, we would like to know an issue so that we can track them and work towards unblocking.
Yeah, let me quickly, to emphasize that, let me also share the URL to the JavaScript SDK. So to have folks have that handy as well. There we go. So this is basically the new home of the Spin JavaScript SDK. And as Karthik mentioned, if you have further questions or you stumble upon a node package that does not work as you expected it to do, just let us know. We will try to figure it out where and why things went sideways and try to correct as fast as possible. Cool. This was awesome. Thank you, Karthik, for walking us through all the new improvements of the Spin SDK for JavaScript, and also quickly adopting to my silly questions and silly asks for implementing an app.
Yeah, well, this was a lot of fun.
Great. So also to all the watchers out on YouTube, thanks for tuning in. And if you watch that, the recording of our live stream, just keep comments coming. We have an eye on those, and we are happy to have a conversation about all the things JavaScript in Spin. With that, enjoy the rest of the day and see you for the next episode of Fermyon Live.